Okay, YouTube, in this video I'm going to go over the procedure for converting between degree measurement and radian measurement, going back and forth between these two things. So since we're going to be doing this often, and honestly we need to be able to convert into radians more if you ask me, but sometimes it's nice to convert from radians back to degrees to think about situations. We need to memorize these two simple conversion factors. So we say to rewrite a degree measurement in radians multiplied by pi over 180. So essentially, first thing I want to write is this: d to r, degrees to radians. When we want to go from degrees to radians, keep in mind that this is very true. 2 pi radians, we say on a rotation here, 2 pi radians is the same thing as 360 degrees. This is a given fact. It is just that since 2 pi is the 360 degrees, we say that this is the conversion factor we would use, just like we would use like 12 inches, 1 foot, essentially. That's pretty pathetic. Sorry, 100 centimeters for you worldly folks, over 1 meter. But basically, we use conversion factors, and we say that these two things, they really mean the same thing. Just like 12 inches means 1 foot, we can multiply by this to get units to cancel out, as well as acknowledge the fact that really what you're multiplying by is 1, because 12 inches and 1 foot goes into this one time. So technically it doesn't change what you're dealing with. So the fact that we would use this as a conversion factor leads us to this pi over 180, because what I know is that this 2 and 360 share a common factor of 2. So this becomes pi over 180. And so we could multiply by a different conversion factor. We could say, I want to multiply by pi thirds radians, which is a 60-degree angle, over 60 degrees. It's just that this is the most elegant form of our conversion factor. And by elegant, I don't mean beautiful. I mean that it's simple. It does the job. So we say pi radians and 180 degrees, they are simply the same person. So if I want to go from degrees to radians, I'm going to multiply by pi over 180, and if I'm going to go from radians to degrees, r to d, we're going to multiply by 180 degrees over pi. And the simple fact is, you're just trying to choose the one that gets units to cancel out. So I always look at it this way: if you're taking degree measurement and going into radians, put the pi on top, because technically it's pi rad over 180 degrees. We just don't write rad on it because we don't need to. So if I had 110 degrees here, which is what I do have, and I want to convert this to radians, I'm going to say this is 110 over 1, 110 degrees over 1. But the reason why we choose to multiply by pi over 180 and not 180 degrees over pi is because when I put this 180 degrees down here, the first thing that happens is that I get my units to cancel out. And you notice that I'm left with multiples of pi here. So essentially, this is a radian measurement that we're dealing with. I could write radians, pi radians. It's just that we say that we don't have to because it's a unitless measure. So we'd say, all right, well, what I get here, and I should do cross-reducing before anything else. I could say, well, this and this share a common factor of 10. So multiplying straight across, what we get is we get 11 pi 18ths, which isn't, the prettiest angle here. But you could imagine on a unit circle, if I were to split this up into 18ths, we say this is pi, then this is really 18 pi 18ths. And so to say a 110 degree angle, it's like saying if you were to take this 180 and split it up 18 ways. Each one would be 10 degrees rotated, and we have 11 of these 10 degree angles, which is 110 degrees. So you can imagine 18 different pie slices up here, of which we're coloring in 11 of them. And so that would give us what we need there, where this would be, I guess, 9 pi 18ths would be pi halves. So it would be 2 pi 18 or 2 10 degree angles past this, which is 110 degrees. So now looking at this negative pi ninths, this is an interesting thing. We say negative pi ninths. Well, first of all, where would this be? Like what quadrant would this be in? Would this be in quadrant 1, quadrant 2, 3, or 4? And I often find that people, they can't tell me in radians when they're first learning these things. We know that it starts on the positive x-axis here, but essentially it rotates clockwise. And if we were to deal with pi ninths, we say this is negative pi rotation here. This would be negative 9 pi ninths. So you almost have to imagine there's like 1, 2, 3, 4, 5, 6. I don't even know if I did this justice. 1, 2, 3, 4. 1, 2, 3, 4. I think you would have 9 total slices here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. We're just rotating one of these ninths of our way to pi right here. This is negative pi ninths. So when we find this in degrees, it should be reasonably, something between negative 0 or sorry, 0 and negative 90 degrees, somewhere in the fourth quadrant. Okay, you write Q4 also. So when we take this negative pi ninths times either 180 degrees over pi or pi over 180 degrees, we are assessing the situation here and saying which one would get rid of our pi. Get rid of the radians, take me into degrees. And I always just remember this. If you want to go into degrees, put the degrees number on top. That's what you remember. But we're going to multiply by this, and instantly our pi's kick out. And we say that 9 and 18 share a common factor, so certainly 9 and 180 share a common factor of 9. So we say we get negative 1 times a positive 20, we get negative 20 degrees. And this is over 1 times 1, so we get negative 20 degrees. In other words, negative pi ninths is a negative 20 degree angle, and you could think of this as being entirely reasonable because negative pi ninths, keep this in mind, is the same thing as negative 180 degree ninths, which a ninth of 180 is this 20 degrees right here. That's how you convert from radians to degrees or degrees to radians. Cheers.